Bismillah ar-Rahman ar-Rahim. Let's look at OCW 31. Express the moment of the couple acting on the frame in a Cartesian vector form. The forces are applied perpendicular to the frame. So these forces are perpendicular. Okay. Set force 380 Newton and D is 4 meter. First of all, he wants to find out at the angle theta. Initially, he wants at 0. So let's look at initially when theta equal to 0. As we mentioned in class, we have to do it. Let's just name this. This is 4 again. Let's just name this one A or A, and this is B. We should take it, this time I'll take it with every angle in a different position. Let's go from B to A, this angle 0, just like you could do it the other way and use this force. So I'm going to go from B to A. Okay. So what is the coordinate A? The coordinate A is, when the angle is 0, it will be 3 meters. So 3 meters in the x. 3, 0, 0. And that is A. And how about if you want to find out, oh, no. This is 3, 0, 0 meter. Okay. And let's find B. B, when theta is 0, which means it's at this level, this is 3 in the x and 4 in the y. 4 in the y, and of course it's on the floor, so it's 0. So now we will do PA. PA, which is mean A minus B, 0 minus 4, 0. Okay? And that is PA that we need to find out the position vector at. So we will do theta is equal to 0, the moment of the couple. Let's form the determinant ijk. I'll put 0 minus 4, 0. And I'm going to put this force, which is going to go in the positive z, 0, 0, 380. So moment C, the I, it is minus 4 times 380. The J, 0 minus 0, well, K, 0 minus 4 times 0. So there's only one moment, couple moment in the I. Let's do 4 times 380. 380 times 4, that is minus 1,520 I. 1,520 I, and that is, the force is in Newton and the distance is in meter. So the units for this moment is in Newton meter. Okay, so 1,520, we put it in the I, so we put minus 1,520, we put here 0, we put here 0, and that is the unit which is correct. And that's going to be the answer that we have from that problem. Now, let's do this is 4 meter and this is 380. For the angle, the other angle, which is like 10 degrees, which means that if you have the angle, let's look from this side. If you look from this side all the way until this point, okay, and you'll have an angle, which is a very small angle, 10 degrees. And since they mentioned here that the forces applied are perpendicular to the frame, which means that it is perpendicular from the frame, so it's 90 degrees. If you extend it to this point, okay, so let's have the red. So if this is 10, this is 90, that's 100. So what's the remaining of the triangle? 100 minus 180, so it's 80. So the remaining is 80 degrees. And that is the force angle with the x-axis. So if you extend the force like this is going to be the y, this is going to be the x, okay? So this is going to be the angle theta, because this is بالتبادل, it's in front of it. This is going to be the force 380 cosine 80, and this is 380 sine 80. Let's do it using our calculator and see. 80 cosine times 380, and that is 66. Of course, that is in Newton. And sine 80 times 380, sine 80 times 380, and that is 374 Newton. Okay, so let's, we have the forces now. We have the forces. So we have, let's do it, since we took this force, let's do it, did we call this one, what did we call this one? Let's just call this one A. What did we call this one? This is A300, yes. And we call this one, yes, B. Let's do the position vector A to B and use this force. Since we analyze the force into two projections, one in the x, one in the y. So we'll take position vector AB. So position vector AB, which means B minus A, 3 minus 3, 0, 4 minus 0, 4, 0 minus 0, 0. And that is the answer here. That is AB. And we have the forces. And you could notice here that this force is a positive. It is in the positive x-axis. You can see this is the positive x-axis. And this force, negative, because it is in the negative z. The positive z is up. Okay? So the positive z is up. This is a negative z. Okay, let's do the moment, couple moment for the angle at angle 10 degrees. I, J, K, it's 0, 4, 0, and the forces, one is positive, 66 positive, and one is negative, minus 374. So the moment of that couple at 10 degrees, let's see the I, it is 4 times minus 374. Okay, and the J is 0 times that, minus 0, so there's nothing for the J, plus K, 0 times 0, minus 4 times 66. So minus 4 times 66. Okay, so this is equivalent to, let's see, 374 and the minus 374 times 4, and that is minus 1497. 1497, and that is 1497 that is in the I, and minus 66 times 4, 66 times 4, and that is minus 264K. And you have to put the units here for this Newton meter. So you put minus 1497, you put 0, minus 264, and that's it for this moment of the couple. So you should look at the couple and find out the position vector from that force to the other force, but you have to use the force that you are attaching the position vector to the tail of that force. Okay, we are done from this problem. OCW 330.